Ladies and gentlemen, introducing the all-new game show, Jalebi with Balaji.
ಮುಂಡಾ ಮೋಚ್ತು ಯಾವ ಥರ ಶೋನೋ ಇದು? ಆಗಲೇ ಹೇಳಲಿಲ್ವಾ ಜಿಲೇಬಿ ವಿತ್ ಬಾಲಾಜಿ ಅಂತ? ನಾ ಜಿಲೇಬಿ ಸುತ್ತೀನಿ, ನೀವೆಲ್ಲ ನೋಡ್ತೀರಾ. ವಿಶೇಷವಾದ ಸಾನ್ನಿಧ್ಯದಲ್ಲಿ ನಾ ಮಾಡೋ ಶೋನ ಯಾರೋ ನೋಡಲ್ಲ, ಇನ್ನು ಈ ಥರ ಶೋನ ಯಾರೋ ನೋಡ್ತಾರೆ. ಓ ಸರಿ ಹೋಯ್ತು. ಕಾಫಿ ವಿತ್ ಕರಣ್ ನೋಡ್ತೀರಾ, ಮೊಜಾ ವಿತ್ ಸೃಜಾ ನೋಡ್ತೀರಾ, ಜಿಲೇಬಿ ವಿತ್ ಬಾಲಾಜಿ ನೋಡಲ್ವಾ? ಏನಾದರೂ ಮಾಡ್ಕೊಂಡು ಸಾಯ್ರಿ ಮುಂಡೇವ. ಓ ಅಲ್ಲ ನಿಮ್ಮ ಪಿಂಡ. Now before we start with our today's topic, let us start seeing what we did in our previous session. In our previous session, understanding arrays, we saw arrays are structures that hold multiple values of same data type in a single variable. Arrays belong to a category derived data types and they are immutable in nature, that is fixed in size. We understood the syntax of declaring and initializing an array through various illustrations and examples. In Java, declaring a variable and initializing a variable are two different processes, and it is strictly prohibited in Java to use or access any variable before you initialize the same. Arrays in Java are just objects, and every time a new object is created, default values are stored inside every index of an array. Arrays in Java can be of any data type, and an array can be accessed in Java using something called an array index. We saw array index in Java always start with 0, and as a result the array index here will always end with array length minus 1, that is n minus 1. In Java, length of an array in real time can be accessed programmatically using a variable by name length. With the help of a program Arrays Demo 3, we had to use a syntax z.length to access the length of an array bearing a name array z. We later saw single line array initialization, which will declare, initialize and feed new values to an array in one single step. Last but not the least, I gave you 2 mini assignments and one program to analyze, which are very important if you are really serious about your programming career. Assignment madilva? ಎಲ್ಲಾನ ಹೋಗಿ ಒಡಿಸ್ಕೊಳ್ಳಿ, ಯಾವನ್ ಕೇಳೋದು ನಿಮ್ಮನ್ನ? ಎಷ್ಟು ಅಂತ ಹೇಳೋದು ಒಳ್ಳೆ ಮಾತಲ್ಲಿ.
Building Block No.6, the literals.
A literal simply means value that can be stored inside a variable. The only thing you want to consider while storing a literal value is you have to make sure that it matches the data type of both the variable and the literal value to be stored. You must have already used many literals by now if you have seriously practiced all our programs. So let us not waste much time and move on with classification of literals.
Classification of literals.
Literals are classified as 5 types in Java. That is A. Integer literal, B. Floating point literal, C. Boolean literal, D. Character literal, and E. String literal. An integer literal is a collection of digits without any decimal points. Integer literals are again subdivided into 3 types. That is decimal integer literal to the base 10, octal integer literal to the base 8, and hexadecimal integer literal to the base 16. ಏನು ಎಲ್ಲೋ ಕೇಳ್ದಂಗಿದೆಯಾ? ನೆಟ್ಟಿಗೆ ಇಂಜಿನಿಯರಿಂಗ್ ಕಾಲೇಜಲ್ಲಿ ಕಿವಿ ಕೊಟ್ಟು ಕೇಳಿದಿದ್ರೆ ಈ ಗತಿ ಬರ್ತಿತ್ತಾ?
More into integer literals.
In integer literals, we have A. Decimal integer literal, which is a collection of digits 0 to 9 and follows base 10. For example, numbers that we use in our daily life like 127, 387, etc., etc., etc. B. We have octal integer literal, which are a collection of digits from 0 to 7 and follows base 8. In Java, to write an octal integer literal, it should start with 0 for the JVM to recognize it as an octal number. For example, 0765, 0145 are examples of octal numbers that are represented in Java. And C. Hexadecimal integer literals, which are a collection of digits from 0 to 9 and A to F, both in lowercase and uppercase, that follows base 16. In Java, to write a hexadecimal integer literal, we should start the number with 0x for the JVM to recognize it as a hexadecimal integer literal. For example, 0x56AD is a hexadecimal representation of a numerical value 22,189 in decimal. If you don't know what is base 10, base 8 and base 16, chill. Don't push yourself too hard, as nobody uses them much in the industry today. I am just explaining you the above things only to show that even Java supports the above features. That's it. Next topic is floating point literals.
Floating point literals in Java.
Floating point literals is a collection of digits from 0 to 9 with a decimal point. There are two ways of representing them in Java. They are A. Standard notation, for example 750.987, and B. Scientific notation. The same number can be represented as 7.50987E2. I seriously don't know what these notations are. Oh wait, I studied this in my PU math. Well, who cares? Next topic is Boolean Literal.
Boolean Literal in Java.
A Boolean literal can have only two possible values. One is true, other one is false. As I have explained in my previous videos, both are keywords and both should be used as it is in a program. Next topic is character literal.
Character literal in Java.
A character literal in Java is a single character enclosed in single quotes. As I have explained in my class data types, a character can be of an alphabet, a numerical digit or a special character symbol. Next topic is string literal.
String literal in Java.
A string literal is nothing but a set of characters enclosed with double quotes. For example, hello world, Indiana Jones, etc., etc., etc. I hate this boring theory class. Can anyone stop this guy? Yeah. That's a perfectly valid string literal. Pinda. Yeah, even that too. Literals was very easy, right? I know. You understood this topic instantly. In fact, 99% of you who have actually practiced our previous examples will pakka find it easy. You all want to know why? Because you are all my sweet students, good students, who are very serious about their careers. In ಕೆಲವು ಇವೆ ದ್ರಾಬೆಗಳು. ಫಸ್ಟ್ ಫುಲ್ ವಿಡಿಯೋ ನೋಡ್ಬಿಡೋದು, ಆಮೇಲೆ ಆಫ್ ಮಾಡ್ಬಿಡೋದು. ಪ್ರಾಕ್ಟೀಸು ಇಲ್ಲ, ಮಣ್ಣಾಗಟ್ಟಿನೂ ಇಲ್ಲ. ಅಲ್ಲ ಕಣ್ರ, ಕೋಡೆ ಮಾಡಿಲ್ಲ ಅಂದರೆ ನಿಮಗೆಲ್ಲ ಏನರ ಅರ್ಥ ಆಗತ್ತೆ. ಇನ್ನು ಮುಂದೆ ಎಷ್ಟಿದೆ ಗೊತ್ತಾ? ಈಗಿಂದ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಬದುಕೊಂಡ್ರಿ. ಕೋಡೆ ಮಾಡಿಲ್ಲ ಅಂದರೆ ಆಮೇಲೆ ಅರ್ಥ ಆಗಲ್ಲ, ಹುಷಾರ್. ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್ ಈಸ್ ಎಸ್ಕೇಪ್ ಸೀಕ್ವೆನ್ಸ್.
Escape sequence in Java.
Before understanding what are escape sequences, first go to D drive, workspace and then go to basic examples folder. Create a new folder by name 04 literals and inside this create a new program file by name escapesequencedemo.java. Now edit the file using edit plus and type the same program as seen in scenario 1. Please note, while typing the program, always make sure you don't commit any syntax errors. The program should be of word to word and letter to letter accuracy. Reason being, even if you miss a small semicolon or you haven't closed a flower brace, Java will never allow you to compile the file. In this demo program, all I have is a print statement which says Ramu is a good boy. Now if I want to add two double quotes to the word good and then try to print the statement, we will get a series of compilation errors as seen below. The main reason for the error to occur is the confusion which is getting created as there are multiple double quotes in a single statement. The only way now to print the statement with double quotes is by using something called escape sequence. Java gives us a set of escape sequence characters where each value signifies a particular functionality. For example, to get double quotes printed inside our string, use escape sequence version for double quotes, that is backslash with our double quotes character attached. That's it. Now compile the program and kaboom! You will get 0 compilation errors and your output will be appearing with quotes once you run the program. Congratulations! Let me show you one more scenario where escape sequence can be used. In this program, there are two SOP statements. That is, SOP Ramu is a good boy in the first line and SOP Chutki is a bad girl in the second line. Once you compile and run the program, the output of the program will be two different statements in two different lines. Now our question is, how to get the same output using a single SOP statement? Yeah, how? All you need to do is add an escape sequence, that is \n, in between two statements as seen here. That's it. Yeah, that's it. Now compile the program and run the code by pressing Ctrl 1 and then Ctrl 2. Kaboom! You have the same output as seen before. And the fun part is, there is only one SOP statement to print these two lines. Congratulations! Remember, when you are using string literals, you might need the following escape sequences, which will definitely come in handy. Take a look. The following table will come in handy while using escape sequences in Java. Please write it down. \single quote for single quotes, \double quote for double quotes, \\, for backslash, \n for new line, \t for tap space, \b for backspace, \r for carriage return and \f for form feed. You will be using more of these in our advanced programs. Practice today and be ready for a better tomorrow. And that completes my explanation for literals. Now it's time to learn a very important building block in programming, operators.
Building block number 7, the operators.
An operator is a symbol used in a program to execute an operation. Consider an addition operation int c is equal to 4 plus 5. Here numerical 4 is known as the first operand and numerical value 5 is known as the second operand. The symbol used in between is known as the operator, which actually performs the addition operation. Once this operation is done, we get something called as a result that even our primary school kids will understand. So why waste time here? Let's proceed further. The operators in Java are categorized as below. That is A. Arithmetic operators, B. Unary operators, C. Relational operators, D. Logical operators, E. Increment and decrement operators, F. Bitwise operators. Let us start seeing one by one, starting with number 1, arithmetic operator.
Arithmetic operators in Java.
In arithmetic operators, we have plus to perform addition operation, minus to perform subtraction operation, asterisk to perform multiplication operation, / to perform division operation, and percentage symbol to perform modulo operation. Wait. You all know what is modulo operation, right? Modulo operation? Now what is that? Dude, you seriously need to learn some basics.
Back to basics.
Whenever you used to perform division operation in your school days, the number in the center was known as the dividend, that is the number you are actually dividing. The number on the left was known as the divisor, that is the number of parts you are dividing a number. The number above was known as the quotient, which was nothing but the result of the division operation. And the difference below what used to remain was known as the remainder. Am I right? Hey, we are not second standard kids, okay? Even we know stuff. Well, know this. In Java, if we divide two numbers using division operator, we get the quotient as our result. And if we try to find the modulo of two numbers, we get the remainder as our result. Try performing all arithmetic operations on your PC. Remember, while practicing these examples, create a new folder by name 05 operators in your basic examples folder. While practicing these examples, create a new folder by name 05 operators in your basic examples folder. Practicing new programs will give you a steady grip in programming. புரிஞ்சுதா? ஒரு வீடியோ பார்த்துட்டு லேப்டாப் க்ளோஸ் பண்ணுறது இல்லை, கொஞ்சம் ப்ரோக்ராமும் பண்ணணும், அப்போ தான் மண்டையில் கொஞ்சம் ஏறும். நெக்ஸ்ட் டாபிக் இஸ் அசைன்மெண்ட் ஆப்ரேட்டர்.
Assignment operator in Java.
A single equal to symbol when used in Java acts as an assignment operator which transfers the value from right hand side to left hand side. This I need not explain much as we have worked on it a dozen times in this series. One more important concept that you all need to know in operators is operator overloading. In the above statement, int c is equal to a plus b, the plus symbol used acts as an addition operator. But in our second statement, which is actually a print statement, we are using the same plus symbol as a concatenation operator. Using one symbol to define multiple operations is known as operator overloading. This concept was evidently used in C++ but had many flaws. Founders of Java rejected the concept for other operators and defined operator overloading only for the plus operator, which does both addition and concatenation operation. Now why they did like that is not that important for your interview, because most of the project managers only won't be knowing what is operator overloading. That's the reason I'm not stressing much about it. But let's see. If I find time in the end of this series, I will explain this topic in brief. Now let us start seeing our next topic, Unary Operators in Java.
Unary Operators in Java.
Java supports unary arithmetic operations. Now before I start this topic, have you anywhere in your life heard what is unary operation? Urinary what? Urinary alvo gubaldo. Unary ಅಂದ್ರೆ ಕೇಳಿದ್ಯಾ? ಸತ್ಯವಾಗ್ಲೂ ಇಲ್ಲ ಗುರು, ಸ್ವಲ್ಪ ಬೇಸಿಕ್ ಇಂದ ಹೇಳ್ಕೊಡ್ತೀಯಾ?
Back to basics.
An operator which operates only on one operand is known as unary operator, whereas an operator which operates on two different operands is known as binary operator. But dude, how can you perform arithmetic operations with just one operand? It's impossible, right? ఎవరు చెప్పింది ఇంపాసిబుల్ అని? ఇప్పుడు చూడు. The statement a plus is equal to 2 is a shortcut for arithmetic operation a is equal to a plus 2. The combination of two symbols used here is nothing but a unary operator. As you can see, there is only one single operand to the right, and the operator beside it is known as unary addition operator. Likewise, we can have unary subtraction operator, unary multiplication operator, unary division operator, and unary modulo operator. The below used operator acts as a single unit and takes less duty cycles in your processor compared to your binary operators. Hence, the performance in your processor will automatically improve if you use unary operators in your program, as it takes less duty cycles. If you are an electronics student or a computer science student, you will be definitely knowing what is a processor duty cycle. Well, if you don't know what it means, chill. It's not a big thing to worry about. Next topic is relational operators.
Relational operators in Java.
Java gives us a set of relational operators whose result will always be a Boolean value. Following are relational operators defined in Java. Starting with number 1, we have the greater than operator, the less than operator, greater than or equal to operator, less than or equal to operator, equality operator, and not equal to operator. Without any proper demonstration, you will not know head and tail how to use it. So let us start seeing one by one and understand how it works. Consider int a is equal to 15, int b is equal to 17, int c is equal to 18, and int d is equal to 17. The operation a greater than b will result in false, whereas the operation a less than b will result in true. The operation b greater than or equal to d will result in true, and so does the operation c less than or equal to d will also result in true. The operation c less than or equal to a will result in false, and the operation b equality d will result in true. The operation a equality c will result in false, but the operation A not equal to C will now result in true.
Confusion alert.
In Java, a single equal to symbol acts as an assignment operator and it is used to assign values from RHS to LHS. Whereas the double equal to operator acts as an equality relational operator and it is used to check whether the two operands are equal or not. The result for this equality operator will always be a Boolean value, that is true or false. So my dear students, please be very careful while using these two operators. In C, I know it would have worked anyway, but sorry, this is Java and Java is a strictly type checked, spell checked and a well-defined language. Mistakes here will not be tolerated and your compiler will pass you an error instantly wherever there is a mistake. So be careful. Next topic is logical operators.
Logical operators in Java.
Logical operators in Java are used to relate two relational expressions, also known as logical expressions, where both operands and results will relate to a Boolean value. The three main most frequently used logical gates in Java are logical OR gate, which is denoted by a double pipe, logical AND gate, which is denoted by a double ampersand, and last but not the least, the logical NOT gate, which is denoted by a single exclamation mark. To understand logical operators in Java, let us start seeing one by one, starting with number 1, logical OR operator.
Logical OR operator.
A logical OR gate is denoted by this symbol all over the world. Here A signifies the first operand, B signifies the second operand and C signifies the OR gate result. The below truth table indicates the result of an OR gate will always be true if any one of the operand relate to be true. Now consider the above declarations. In the below seen logical OR gate expression, the first operand A greater than B relates to false, whereas the second operand B equality D relates to true. As one of the operand is true as defined in the truth table, the result of this logical OR expression is true. Now let us take one more expression for example. Here in this example, the first expression C less than B relates to false and the expression D not equal to B also relates to false. As both the operands are relating to false as defined in our truth table, the result of this logical expression is false. Many of you in your lifetime may not have seen this pipe symbol on your keyboard, which is used to depict logical OR gate in Java. For those students who have never seen, take a look over here. The pipe symbol is present right above the backspace symbol. Next we are going to see number 2, logical AND operator.
Logical AND operator.
A logical AND gate is denoted by this symbol all over the world. Here A signifies the first operand, B signifies the second operand and C signifies the OR gate result. The below truth table indicates the result of an AND gate will always be false if any one of the operand relates to be false. Now consider the variables A, B, C and D with corresponding numerical values as seen over here. In the below seen logical AND expression, the first relation A greater than B relates to false, whereas the second relation B equality D relates to true. As per the truth table defined, one of the relations has turned out to be false and so the output of this logical expression will also be false. Let us take one more expression for example. Here the first relation C greater than B relates to true. The second relation A not equal to D also relates to true. As both the relational expressions are turning out to be true based on the truth table defined, the output of this logical AND expression is true. Now it's time to see one more important operator, logical NOT.
Logical NOT operator.
This is probably the simplest logical gate ever. The one you see here is called logical NOT gate. It has only one operand and the result will always be converse of it. The below truth table shows you if the input is true, output will always be false. And if the input is false, the output will always be true. For illustration, again consider variables a, b, c and d. The first relational statement a greater than b relates to false, and so the not of this relation would automatically be true. Likewise, the statement b equality d relates to true, and so the not of this relation will automatically be false. There are few more topics which are pending in logical operators, that is unary AND operator and unary OR operator. Well, if I start teaching this now, I am 100% sure your head will blast overloaded with concepts. So let me skip this topic for now and let us start with a very important topic, increment and decrement operators in Java.
Increment and decrement operators in Java.
Consider an integer variable a which is first initialized to 0. Imagine, in every step if you want to increment its value by 1, you as a programmer needed to do addition operation in every line, which is a very painful task. Likewise, consider another integer variable b which is first initialized to numerical value 100. Java gives you a flexibility of using increment operator, which is a shortcut for one increment addition operation, and the decrement operator, which is a shortcut for one decrement subtraction operation as seen here. The two consecutive plus symbols acts as an increment operator, whereas the two consecutive minus symbols acts as a decrement operator in Java. Some Brahaspatis in my class might ask, what are pre-increment and post-increment operations? I have only one answer for them. First, ಹೇಳ್ಕೊಟ್ಟಿದ್ದನ್ನ ನೆಟ್ಟಿಗೆ ಕಲೀರಿ. ಅತಿ ಬುದ್ಧಿವಂತಿಕೆ ತೋರ್ಸಕ್ಕೆ ಹೋಗಬೇಡಿ. ಅರ್ಥ ಆಯ್ತಾ? Next topic is bitwise operators.
Bitwise operators in Java.
Java gives you a set of operators by name bitwise operators, which helps you to manipulate the bit values inside your variables. The bitwise operators in Java include left shift operator, right shift operator, bitwise AND operator, bitwise OR operator, bitwise NOT operator and bitwise XOR operator. As a programmer, I have never used these in any of my applications, nor have my seniors used in their applications. If you are a digital electronics student, probably you might get a requirement to use all these operations. Others chill. You might maximum need this in telecom domain, but in other places hardly you will get a chance to use them. Now my friends, here comes the boss of all operators, ternary operators.
Ternary operators in Java.
A ternary operator in Java operates with 3 operands. Yeah, 3 freaking operands. Consider int a is equal to 15 and int b is equal to 17. Suppose I have a condition. If a greater than b, I need to perform a subtraction operation, and if a is not greater than b, then I have to perform an addition operation between two numbers. Now that's a solid condition, and with ternary operator you can perform this in one single line. What? In one single line? How? Yeah, take a look. Here is operand 1, here is operand 2 and here is operand 3. The in between question mark and colon used is nothing but our ternary operator. The logic behind ternary operator is simple. If the condition in operand 1 turns out to be true, the ternary operator will execute operand 2. And if the condition in operand 1 turns out to be false, the ternary operator will execute operand 3. Well, I know you have not understood this ternary operator so perfectly, but the only way that you can understand this topic is by coding. So move up your lazy bums, type what is seen and practice to become perfect. Note down the truth tables for all 3 logical operators, and please make notes for everything what I say, or else you will end up in soup later. Do text us your doubts on WhatsApp if you have any, so that we can solve it for you. Remember, you understanding the subject is our topmost priority. Subscribe to this channel to stay updated for our next video release. Till then, this is Balaji.K.R signing out. See you soon. Muchkond Kodmadi.